Hello friends, so today we can discuss a very interesting problem from the AtCoder regular contest 103, problem C. So I'm hosting regular contest on my Telegram channel, so do check it out if you are want some practice more in competitive coding. So you can join the contest. I post contest every 3 to 4 days, so you can brush up your knowledge on different concepts. And this is one of the questions I asked in today's contest. So let's see this as a tutorial for that contest, and let's start. So the question statement states that a sequence a1 till an is said to be in this format when the following condition is satisfied. The condition is that for each I 1 till n minus 2, ai is equal to ai plus 2. So let's put some value. If I is equal to 1, then it is equal to 3. Then I equal to 3, it's equal to 5. So all the odd numbers are same and all the even numbers are same. So first try to absorb the question. Try to understand every line of it. I'm telling you how I read the question and how I understand the question. Okay. The second point is exactly two different numbers appear in the sequence. So it cannot happen such that all the elements can be 5 5 5 at the even position and 5 5 5 at the odd position. That cannot happen. Okay, so there should be two different numbers, and all the numbers at the even position and all the numbers at the odd position should be same. So that's the two questions and two conditions I have to take care of. Okay, so now the question statement states that you are given a sequence whose length is even. Okay, it means that there are even even number of odd and the same number of even numbers and odd numbers indices, and you have to make that sequence into this format by replacing some elements. So you have to take out some elements such that the final sequence should be in this format or of this type. Find the minimum number of elements that you have to replace, and that's the question. Now what you can see here is always try to draw out some test cases to make it the question even more clear to you. So let's draw out some test cases. Let's assume that there are 6 positions, and let's assume that there are this number. So it's always beneficial to find out the maximum number at the even position and take that number and then remove out the element which is not maximum. So let's assume that there are 3 types of numbers at the even position and we know the frequency of every number. Then we want that the number which is maximum should stay at the even numbers and all the other numbers should be replaced. That's the whole trick. And same for the odd position. We can find out the count for every number at the odd position and then retain the maximum number at the odd position and then replace all the other numbers. That's the simplest thing you can think over this question. But now there can be some edge cases. First try to see, okay, the first thing which I have seen in the question is that the number at the even position and the odd position should be same, but they cannot be same as well. All the numbers at the even position and odd position cannot be same. So let's assume that there can be a case in which they all are 5. There are 5 date numbers, 6 positions, and all of them are 5. Now what will happen? If we find out the count for even position, it is 5, which is maximum. If you find out the count for odd positions, it is 5 and it is maximum, then there is some problem. So it means that I have to find out the count of the first maximum and the second maximum. So there can also be a case such that I can take the maximum number which occurred at the even position, and because if the maximum at the even positions and the maximum at the odd position by frequency are same, that 5 occurs at the maximum time at the even position and 5 also occur at the maximum time at even position, only at that condition. If they are different, then just print out the maximum cases and so on. But if they are same, then we have some edge cases in which we can either take all the numbers at the even position, the maximum one, and at the odd position, the second maximum. What I mean by second maximum, because I have the frequency of every element at the odd position, because I'm not taking the maximum element, I will try to find out the second maximum, because it will only increase my alphabets by little bit, but this is beneficial because I am using the second maximum one. Or else I can also do what? I can take out the second maximum for the even position and the first maximum for the odd position. That can also be done. But let's assume that there is a chance in which there is only one type of element in the even position and the same type of element in the odd position. In this case, there is no first maximum or the second maximum. There is only one element. In that case, I have only one choice: to replace all the elements at the even positions or replace all the elements of the odd position, because I have only that choice only. But because all the elements are same, it can also, like, it's up to you. You have to find out the minimum among all of the following cases I've discussed, and that's the whole logic. It's nothing more complicated in this. I have to just find out the minimum among all the cases I've traveled. I have to just find out the minimum among the even positions, odd positions. If they're different at the frequency level and they are not same by the number level, just put it down. Else if they are same, then find out the second maximum at the odd position and first maximum at the even position, first maximum at the even position and second maximum at the odd position. And if they have both the same length, then like take one and the other, just replace all the odd positions, and that's it. That's the whole trick for this question. So let's move on to the code part now to even make it more clear. Take the input of n numbers and like store them in this array, then make a map for the even positions. Iterate over all the even positions and make a map for them. Then make a pair for even position, because I have to store the frequency as well as the element number, because I have to match that the first maximum and the second, the maximum at the even position and the maximum at the odd position should not be same. So I have to see the element number also and the frequency as well. So I have to store the frequency as well as the element. So after I've populated the map, I will iterate over the map, and then I will push in the map. The second represent the frequency and the first is the number itself, and then I will clear the map, and then I will do the same for the odd numbers. And then after that I have stored the frequency at the first position and the number at the second position in this map of even and odd. Then I will sort them, because I have to find out the maximum for the even and the odd number. So I will sort them, because after sorting in this format, it will put the smallest number at the start, but then I will reverse it to make it decreasing order. Then I have to minimum among the following cases. So what will I check first? Because after sorting the first element of the even and the odd, if they are different, so I will check the first element of the even position of the second will tell us the element number. If they are different, then the answer is minimum among, like, the whole minimum. And what we'll do, because there are n by 2 even numbers and n by 2 odd numbers, I will replace, because there are like this is the maximum number of even numbers present. So I will not touch them. I will only touch the number which are not same, because I want that all the even position numbers should be same. This is the maximum frequency number which occurs at the even position, so you should not touch them. You should only touch the number which are not equal to that number. So how you can find out? Total number of even positions, total number of even numbers, minus the number which is not equal to that, or the minus the frequency of the number which is not equal to the number we are talking about. So even of 0 minus first, and same for the odd position. But if the number at the even position which is maximum and the odd position which is maximum is same, then what we'll do, we will have to check that we will either take the maximum of the even and the second maximum for the odd. But to check for the second maximum of the odd, the size of the odd should be greater than or equal to, then only we can take the second element. If the length of that is not equal, which means that there is no second maximum, how we can take out the second maximum? You have to first check. So if the second maximum exists, then only what we'll do, we will do the same, first maximum for the even and second maximum for the odd. Or else, if the even length is greater, we will take the first maximum for the odd and second maximum for the even. Else, if both of them are like not satisfying this condition, then what we'll do, we will take out the first maximum for the even and change all the n by 2 positions for the odd position, which what I've told. Take the even position length and change all the odd position lengths, and else also do the same for the odd positions, and then find out the minimum among all of these cases and just print out the minimum. I hope you understand the logic as well as the code for this question also. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.